Okay, these notes are on implicit differentiation, and it's one of those pretty tough topics, so I really need you to find somewhere that you can go sit and really pay attention to this. Once you do it a few times, I think you'll find that it's really enjoyable, but we have to get to doing it a few times. That's the fun part. Okay, so basically this happens anytime you have a situation where you can't write f of x, y equals 0 in the form y equals f of x. Basically, the gist of it is anytime you have, oh my goodness, how am I going to do this? A y in with your x, and you can't just solve for y. That's when you're going to use implicit differentiation. So here's another situation. You can see here, this is obviously y is not a function of x here. It doesn't pass the vertical line test. This would be an example of where you'd have to use implicit differentiation. Here's another example. And now let's do one. Oh, here's another example. Now let's do one. So here's your problem. Okay, x squared plus y squared equals 1. I wish this hadn't all shown up. Ignore the bottom, just look right here. You can see that this doesn't pass the vertical line test. This is not going the way I wanted it to, because it's not a function, but we're going to treat y as a function of x. So we're going to say that y is just f of x squared. So now when you take the derivative of this, you know how to do that. Derivative of the first one's 2x. The derivative of here, you have to do the chain rule. So it's 2 times f of x, which we said was y. Remember, we called, in this case, y, we called it f of x. So you do 2 times f of x and then times the derivative of the inside. So it looks like this. 2x, because that's the derivative of x squared, plus 2 times f of x, because that's the chain rule, times the derivative of the inside. And then we go back and replace f of x with y. So it's 2x plus 2 times y prime equals 0. All you have to remember is whenever you have a y in the problem, you take the derivative just as if it was an x, but then you always have to multiply by the inside, which is y prime, because y is a function of x. Okay, so now we would solve this equation for y prime. So we have 2x plus 2y times y prime equals 0. We would subtract 2x from both sides, so 2y times y prime equals negative 2x. Then we would divide by 2y, so y prime would equal negative 2x over 2y, and then we would divide those, and y prime would be negative x over y. So then to find the slope of the tangent line, remember this is the derivative, y prime is the derivative, so this is the slope of the tangent, so we have to plug in x and y to find the slope of the tangent. So we would do negative 1/2 divided by root 3 over 2. Well, remember, when you divide fractions, you keep change flip. So negative 1 over 2 times 2 over root 3 gives you negative 1 over root 3, which we simplify to be negative root 3 over 3. That's the slope of the tangent line, negative root 3 over 3. Is there another tangent line parallel to this? Well, of course. This is where, oh geez, that's a bad picture. Where x is 1/2 and y is root 3 over 2 is right here. So there's obviously another tangent line down here. So we're not going to find that equation because we don't have the x value. I mean, if we plugged in negative 1/2, then we would. But the bottom line, this is what you have to get out of this whole thing. Whenever you have a y in the problem, you take the derivative just as if it were an x. If this was x squared, the derivative would be 2x. So the derivative of this is 2y. But then you have to multiply by y prime. You have to do the chain rule. Let's try this one. So you can't solve it for y, so we are going to take the derivative of everything. Well, the derivative of 4y is 4, but then you have to multiply by y prime, equals 2x plus Now here we have the chain rule again. 8 times the derivative of sine, which is cosine 7y, times the derivative of 7y is 7y prime. Remember, whenever you take the derivative with y, you have to take the derivative of y, which is y prime. So to simplify this and to solve for y prime, we would say 4y prime equals 2x plus 56y prime cosine 7y. And then we would subtract that from both sides. And I think I actually have this all typed out nicely. So 4y prime plus 2x 8 cosine, and then we did all that. Chain rule. Subtract that from both sides. Oh, right. My math was horrible. Hold on. Can I go back? No. This is one big term that's all being multiplied together, so you can't just subtract the 56y prime. You have to subtract the whole thing. Sorry about that. Okay. And then when you do that, you can factor out a y prime, and you're left with 4 minus 56, and then you divide both sides by that. So remembering to do the y prime isn't usually the hard part. Solving for y prime usually gives people some trouble. So then you divide both sides by this whole term, and that is your y prime, also written as dy dx. So here are your steps. Differentiate both sides with respect to x, solve for dy dx, or y prime. These mean the exact same thing. X squared y equals 5. And the directions are find y prime. Okay? So this is product rule. So we're going to go first times derivative of the second plus second times derivative of the first, and that equals 0. Derivative of 5 is 0. So to solve for y prime, we would subtract this term. So we'd have x squared y prime equals negative 2xy. Divide by x squared. So y prime equals negative 2xy divided by x squared, which is negative 2y over x. That's all you do. There's y prime. Okay, last example. I hope this is working. Doesn't sound like it is. It better. Okay. We're going to write the equation of the tangent line to this circle. Hopefully you know that's a circle. At the point 0, 0. So, chain rule here. 2 times x minus 3 to the first times the derivative of the inside, which is 1. Plus, let's get a little focus action here. 2 times y plus 4 times the derivative of the inside, which is y prime, equals derivative of 25 is 0. Now this is a perfect example where we could go through and solve for y prime. And if we do that, we would see that you have 2y prime times y plus 4 equals negative 2 times x minus 3. Divide by 2 and y plus 4, and you get y prime equals negative 2 times x minus 3 over 2 times y plus 4. Those cancel out. You get negative x plus 3 over y plus 4, and you plug in 0, 0, and you get that the slope is 3/4. But it would have been easier to just plug in 0, 0 here, and you would have 2 times negative 3 plus 2 times 4 y prime equals 0. So you'd have negative 6, you add it to the other side, 6 divided by 8, and you'd end up with 3/4. So the equation of the tangent line is y, I'm not going to write minus 0, equals 3/4 times x. Again, I'm not going to write minus 0. So that's implicit differentiation.